Another draft physics video presentation. This one, whatever. Fake physiker of the week, more fat-headed physicist of the week. Yeah, I think we'll go back to those awards. And this year's winner might be, might win for the whole year. AB Science. Such a douche. So he's made a video, Mechanical Explanations for Gravity, and, pretending to deal with the real argument. The fact that actual mechanical explanations come with the liability of having to explain implications of things. Like, unlike inventions like dark matter, that don't carry any implications because it's magic matter. Matter that just creates gravity and doesn't do anything else in the universe. Real explanations come with the liability that real explanations have real consequences, side effects, that have to be accounted for. So it makes it a lot tougher. It's a lot harder to come up with a real explanation than to come up with a gremlin, bent space, empty, vacuous. I'm just going to pretend, I'm not going to call it Mr. Magic, but it still has all the attributes of a Mr. Magic explanation. I mean, bent space has all the attributes of a gremlin theory. I mean, it's just a magical substance that allows for this magical event. And they don't have to take any responsibility for explaining things like drag and, the other side effects of this actor, this god that makes things happen, the random god for quantum mechanics. I mean, it's so bad. And it's such a, cheap shot at this process of putting together a rational map of reality and how it should be done carefully, and how clowns like this, this is an anti-scientist because he's just propagandizing. He's taking the information that exists and distorting it and perverting it and presenting it and saying, see, look at my distorted version of reality and how it all works. Well, it only works because it's glued together by a bunch of vacuous, unaccountable magic. And that's it. There's no other reason why it works other than the fact that you've created something magical as an explanation, and therefore everybody's stuck proving, that there was no pumpkin, that Cinderella got to the ball in. We have to prove, the pumpkin. No, you have to prove it. Anyway, and they don't have any way of proving it except for irrational things. Like they'll say, okay, because we found out that radioactive elements decay with slower with velocity. So the more velocity you give them, the slower their decay rate. Because that's a fact, it's a fact that space is bent. I mean, the two really don't have any direct connection. And it's only an incidental connection that we've made clocks out of decaying particles, the most accurate clocks we can make. And that somehow, because of that fact, that means space is bent. And we proved it. And they didn't do anything close to it. So anyway, I'll start with the comments. I won't play the first half because it's just so boring. You could, you lose all reason to live. But anyway, so I left a comment because he does get to the drag subject, and he apparently doesn't even understand the subject. So again, these are physicists. These people think that claim to know something about physics. Some of these commenters and whatnot, and they don't even get the whole idea that there's one universe. Okay, that the electrons and the protons are actually in the same universe. Okay, that we're in the same empty space. The same what we call space. The stuff that doesn't have anything in it. There's no neutrino in it, there's no electron, there's no hypaton or pupaton or kanakaton, no tons at all. That stuff is the same stuff the electrons and protons are in. And that the electrons and protons are clearly the only thing that are actors in this play. Like if you were to say, okay, who's presenting this event that's taking place? Who's making the event happen? Who's doing something? Well, the electrons and protons are the only thing doing anything. everything I'm doing right now is electrons and protons doing stuff. They're doing all the moving. They're doing all the acting. They're doing all of it. There's no me, okay? Me is just a composite of a whole bunch of this crap interacting, sending signals to each other, pushing each other, so to speak, pulling. They're the puppets and the strings and the puppeteer. It's all made on that level of the universe. There is no, I'm doing something. No, there's electrons and protons are doing something. So they don't even get that part of physics, okay? That there's only one universe, and it's made of little tiny stuff, and that's it. That's the only universe there is. So I don't want to, burst any bubbles, but they can't even get fact one right. I mean, there's so many ways to prove it with just logical statements that can be the only cause, that the big things can't make the little things do stuff. The little things are making the big things do stuff. That's the only rational way to look at it. Just as the only way to rationally look at it is that there's push as an elemental function. Two things hit each other. Push. And pull is just not a player. So you either have an absence of push or you have push. But you don't have any pulls. They can't even deductively reason that one as a truth. So they don't even have those as laws or principles. Instead, they have wacky crap like Heisenberg. Woo, 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 woo. The photon knows you're looking at it, and it's hiding from you. It won't let you know things. I mean, it's such a religion. Oh, it's pathetic. So anyway. So on the subject of drag, I posted a comment that I thought might get to get to some kind of, get to the, let's get to it. Let's get to the evidence. So I said, how far does the average beta particle, so this is one produced not by creating a voltage, differential and creating a whole bunch of X-rays and gamma rays and different kinds of rays to push a bunch of electrons across a field, right? Electrons are pushed. When you heat an element, you're obviously pushing, right? I mean, that's just too obvious, right? You get that, right? I mean, I'm shoving a bunch of stuff in, and you're basically saying, wait, the stuff's got to go out somewhere, right? I'm shoving too much in. Some of it's got to leak the hell out. So that's clearly push as a concept. So I've pushed electrons, and then I create a voltage potential, which means clearly I'm creating a potential that moves charge, that moves electrons and protons. It's got to be a field of some kind. A field of what? Oh, well, a field of little bullets, a field of little force elements, okay, that are going to hit it and push it, okay? So the electron's getting pushed because I'm creating a differential, a field that's moving in one direction. More bullets going this way than going this way, the thing goes that way. All right, so that's pretty elemental. There really shouldn't be any hard disagreement about the fact that decay from a radioactive element is different than the movement of electrons we see. There's two ways you can move an electron, have a moving electron. You can sit there and look at a radioactive substance and wait for an electron to fly out of it. Or you can set up one of these contraptions where you heat an element and then further, once you release the electron with the heat, now you put it in a field that's going a stream that's going in the direction you want the electron to go. And so clearly a radioactive element isn't, pushing it by charge. It's not creating a charge differential. So the push is obviously some kind of whatever accelerated the electron is something that's only got one element. It's not dependent on creating a field that's continuous. So whatever energy it had when it left, and now all it can do is lose it. And that's exactly what it does. So the beta radiation just goes, this far, and that's it. It goes this far. That's it. Put it in a cloud chamber, electrons shoot off and run out of gas. So I asked the obvious question. How far does the average beta particle, electron produced by decay, travel in a vacuum? So the big thing is that cloud chambers are full of crap. So obviously you say, okay, the electron ran out of gas because it plowed into a bunch of stuff and made this cloud. It made a bunch of clouds in the chamber. So it clearly is doing a lot of work, so that's why it ran out of fuel. It's because it has to do all this work to make all these clouds so we can look at it and say, there's where the electron is. Even though it's just a trail, footprints left by the electron. We're not seeing the electron, we're just seeing it, what it left behind is rubbish and garbage on its way. So put it in a vacuum and then see what it does. And I would argue that what it does is the same damn thing. Just doesn't go very far. It goes this far maybe, and that's it. Runs out of gas again. Stops moving. Stops traveling. So that's the basic principle. So what I'm saying, where's the evidence? Right? We should have evidence of this, right? There should be somebody who put a piece of radioactive crap inside of a vacuum and then put a shielding around to collect electrons and then said, I'm not collecting any. How come? How come I can't collect any electrons as soon as I get a few inches away? Curious. Unless I apply a voltage again, which is cheating. Anyway, can you cite any experimental evidence showing that electrons don't experience drag? That is, that electrons won't just keep going. We can't make a vessel. We can create perfect magnetic fields. And so this perfect magnetic field would be simulating exactly the circumstance of, say, gravity affecting the moon. The gravity that affects the moon and causes it to move towards the Earth doesn't steal any momentum from the moon. The moon maintains its velocity. It doesn't lose anything to drag, okay, somehow. All right, so it can go a long time. We can't do that. The simple truth is we can't create a vessel that captures these little particles and keeps them going around and around and around. We could just keep filling it up. We could keep just shoving particles in, with momentum, just trap them in a magnetic field and just have them go around and around and around and around. And theoretically, they shouldn't lose any velocity. But they do. That's the truth. All right. So drag seems to be a real thing. So this symptom, they say, makes the theory untenable. That the theory is no longer useful or valid because of this disqualifying fact. Well, the disqualifying fact happens to actually be a truth. Okay, so it doesn't disqualify it. Drag does happen on the elemental universe. Now, some reason it doesn't happen when you get to bigger objects. How come they're not dragged? That would be the question now. All right. So the answers weren't an answer to the question. So apparently nobody knows the answer to the question. But, it's a difficult question because there really aren't experiments. This is like the Eddington thing and all this other crap. We're just told it's the most proven thing in the universe, and yet if you go looking for the proof, you can't find any. All right. So this idiot, really stupid, Scott Meyer, see Newton's first law. So he's going to cite some sort of presumed fact that covers every single particle in the universe. So this, again, is something they do constantly. They're constantly telling us electrons are the same as protons, are the same as buckyballs, are the same as Volkswagens, same as human beings. They're all the same thing. A particle, is the same. It's always the same. Like a life form is the same or something, right? We know we're made out of cells. We know we're made out of living things. Technically we have to be different than, there's a point where you can say everything is bricks, but that doesn't make any sense. It doesn't make any sense. It makes sense, perfect sense for me to say everything's electrons and protons. It doesn't make any sense for me to call everything else an electron or a proton. To say a human being is just an electron or a human being is just a neutrino. That would be retarded. Okay, the Empire State Building is not just bricks. Okay, and you wouldn't call it brick. You wouldn't walk into New York and say brick, 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 brick. You wouldn't call the buildings bricks. That would be stupid. All right, so this idea that all particles are the same thing and they have to obey the same Newtonian law is where, again, smart people should say, oh, wait a minute, you shouldn't do that. Worms aren't the same as grasshoppers, aren't the same as blah, 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 blah. I can go down the list. All right. It will travel on a straight path until it collides with another particle. So again, the whole point is of a particle theory is that the force is made of particles. They were suggested to be ultra mundane. Now, ultra mundane doesn't mean big giant. Ultra mundane it means it's like it can't get more small and mundane in their influence. They would be described as the tiniest things in the universe. And I'd say this is what photons are made out of, and this is what magnetism is made out of, and this is what gravity is made out of, is these ultra mundane little bits of momentum. And it clearly works that way. The light has momentum, gravity has momentum. These are all things they say have no mass and they can't do it. Well, of course they can. And of course they impose it. So again, it's just so silly. So yes, of course. And yes, the ultramundane particles would be different than the un-ultramundane ones, the electrons and protons. Now they're both elemental. Electron is elemental, and proton, I would argue, is elemental. Okay, and and the force is elemental, but they're not the same thing. Electron isn't a photon. Come on, this isn't that difficult. All right. It collides with another particle. Yes, that's exactly the point. The point is the universe is full of little particles, ultramundane particles, and they're constantly colliding with things. And if they collide in a certain way, they produce a certain result. Now, charge means that I think there has to be two types of those things to go with the proton and the electron, but 2 plus 2 plus 2 physics. It's not that many numbers. It only adds up to 6. 6 ideas. Is that too many ideas? 6. You can't follow along. There's 6 parts that you have to put together. Just 6. 6 little puzzle pieces. That's it. And you can't. It's too much for you. All right. Anyway, there is no such thing as a true vacuum. So it isn't about a true vacuum. Who cares whether it's a 999% vacuum or a 4% vacuum? The whole point of the question is, what happens? Do the electrons go substantially forever? Do they stop? Do they what? What do they do when they're in a less cluttered environment? A substantially less cluttered environment. I guess this idiot won't concede that atmosphere is incredibly thin compared to even the lightest piece of matter, and that you can get thinner and thinner and thinner, less and less stuff in the way. Oh, I mean, these people are just so frickin' stupid. Anyway, let's see. There's no such thing as a true vacuum. So again, every time somebody says vacuum, they're obliging there to be an absolute vacuum. I didn't say anything about an absolute. The whole point is that if I substantially reduce the amount of stuff the electron can possibly hit, what is the implication? Does the electron go substantially further? Or another force, gravity, affects it. So again, the whole point of the conversation is that gravity is made out of particles. It's not a force. It's not a magical thing. It's not just some come to me, go away from me message that the thing sends, right? It doesn't have a sign that says fuck off. And the other particle reads the sign and says, oh, he said fuck off. I have to fuck off. What the fuck? Anyway. So that's absolutely useless. The law proves the law. So he's just saying Newton's law proves the law. I don't need to have an argument. I don't need to provide any evidence. I'll just tell you the law is the law. And this is how it happens. When that's not how it happens. Even in, the video, which I'll play eventually. Parts of, anyway. There's one part where he's trying to defeat the particle model and he just shows reflections as being the fact that it would go in this way and reflect at an angle when there's no reason to think that's the rule. There's no reason to say that electrons are affected by the force because the electron's made out of glass and it has, a reflective index or something. There's no reason to think electrons have a reflective index Well, anyway, so mindless marbles again, just such an asshole. If electrons experience anything close to drag, then particle accelerators would have to constantly adjust for the Earth's rotation and movement. That's just absolute fucking nonsense, again, and there's no evidence it doesn't constantly adjust. So this is the joke, right? That accelerators actually aren't able to contain the energy. That clearly the argument is they can't put it in and it stays in there for days. The whole argument is that they're losing it somewhere. It's all leaking out of their system somehow. So, you don't even have evidence of this thing that somehow your accelerator works, because it doesn't. It doesn't contain energy. It doesn't store energy. It loses it all over the place. That's why its electric bill is insane. It's because it can't keep any energy in the system. So that's hilarious. But this is a really important subject. It gets back to the whole conversation with Piro and the fact that the light clock would be able to prove all this. If we could actually do this light clock thing, even what LIGO is trying to do, if we could actually create this device that could measure how much a beam of light, a ray of light, is affected by a force, then this whole conversation could be moot, because then we'd have this piece of evidence that needs to be provided, and there just isn't any. So again, accelerators don't prove the non-existence of drag. That's just a statement. They say it, and they won't provide you any evidence of it. So that's called horseshit, right? Yeah. All right. So what? Oh, I didn't turn my other light on. Well, we might not need it. All right. Just marking my thing so I know where I can draw safely. All right, so there'll be this idea that you have things on the surface of the Earth, so you could just imagine the surface of the Earth. I really shouldn't have to draw that. But the idea is that you could emit light at one point, okay, and it's going to travel a straight line. And that, clearly there would be ways to detect not only the curvature of the Earth, because of the point you'd have to detect the light at, but that you could also prove the fact that the Earth is moving away from the source in some other direction. So the source produces the light. The concession is the light travels in a dead straight line, and it just doesn't care that the Earth has now moved. So the Earth has moved to, say, this location, right? You can still see that, right? Yeah. So the Earth moves to a new location. I'll highlight it in a different color. And now your receiver, okay, is sitting there. It moved out of position. So now you're going to receive it differently. Now, obviously, this is so if I had like a tall ruler and I shot the light, the argument would be is that the light should hit a point on the ruler. But if the ruler is moving, because the Earth is moving, then we should see the light hit a point on the ruler that doesn't make any sense. It's in a wrong location. It's because the light was free when it was traveling, free of all these influences of what momentum the Earth had stored in it. The Earth has a bunch of momentum stored in it. Everything that moves, in free space, a piece of chalk or something, I throw it into space, it has the movement inside of it. It is this piece of chalk and a piece of chalk I throw into space are actually physically different. One of them has a bunch of its nucleuses pointing in a direction, and the other one doesn't. And that's why the one keeps moving, is because it has the momentum in it. So the Earth has momentum in it. The photons don't. Okay? They're not like a baseball on a train. You can't store momentum in them. They're always going to just move one speed. And in one direction. They can't move in more than one direction. They can't store some other direction, run a bent path. All right, so what the obvious problem is that, first off, when you're emitting the light, the fact is that it happens over time. Whether you think it's waves or particles, I say it's particles, you say it's this instead. Is there really that much difference, right? I'm saying it's particles, Okay, it's clumps. You're saying it's waves, right? The real difference doesn't exist if you want to be fair. Okay, the real difference between these two things, right? Because you're conceding that your waves do go in straight lines, that it is possible to have this wave propagate through space and go billions of light years. I mean, you really don't think the same photon that hits me from Alpha Centauri, the same exact photon is going to all places in space. You don't think that's true, do you? Come on. You're not that silly, are you? Anyway. Oh, shit. Because obviously it doesn't hit, if I put a surface here, this wave doesn't hit all these places. So, I mean, obviously it can't be the same wave. You don't think there's a wave that's really as big as the universe. Well, as big as the circular orbit between us and Alpha Centauri, whatever the circular orbit between those two, that distance is. If that was an R, the distance between us and Alpha Centauri was an R. Right, a radius. You know that circle would be humongous, and you really don't think that the wave, there's this giant wave that went everywhere in this whole circumference, and it collapsed right here, and all of this disappeared and didn't do anything. All of this said, forget about it, I've decided not to go to any of these other places, la 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 la, I'm going to go here instead. You really don't think that's the truth, do you? I mean, you're not that fucking stupid, are you? You fell for that? Oh, man. Whew. You're way in over your head in this conversation about reality then. Oh, man. No hope. But anyway, so the idea is that light travels this dead straight line, okay? And this is the whole Einstein thought experiment, the spaceship. Einstein concedes the point. The light travels on its own. It just doesn't care what the emitter's doing. It doesn't care what the receiver's doing. None of that could mean anything to the light. The light just does its thing, okay? And you can screw up, but it doesn't screw up, okay? Light is eternal, complete, fundamental, undistractable, unchangeable in its progression until it meets an obstacle. Some piece of stupid matter has to do something silly for light to even look like it's got any silliness in it. It's so simple and so elemental. Well, anyway, so the idea would be is that you'd measure this difference. Now, the fact is the difference is tiny, okay, at any of the speeds we can even realistically think we're moving at. So, and another thing to consider, you could sort of understand that if it's true, okay, so, I mean, Mindless Marbles has to accept my premise that you can't get free velocity, okay? It doesn't come from nowhere, okay? Velocity comes from somewhere. You have to be, for the Earth to have a velocity through space, it means it had to acquire it in its history somewhere. It had to acquire the velocity. Something had to give it velocity, impose the velocity. So it had to essentially absorb some sort of force going in the direction the Earth is moving. And it had to absorb more force to gain acceleration, to gain more speed. So any speed an object has, you can sort of understand if the universe is in balance, that somewhere else in the universe there has to be this other component going the opposite way. And so that there would be every likelihood that if the moon's going around the Earth this way, and so that that has a net direction of this direction, and then the Earth and Moon are both orbiting the Sun, and so that's a net direction in this way, and then the Sun and the solar system is moving this way, and then the galaxy's moving that way. That eventually all of these momentums would end up canceling each other out. That if they tends to start building up a velocity in one direction, there's going to be every likelihood that missing force in the opposite direction is going to show up. So we really probably don't have any, we're not moving, the Earth isn't moving through absolute space. If you could, most of these people don't believe in absolute space. I mean, that's how fucking stupid they are. They don't think there's really just 3 physical dimensions and there's real places in space. So anyway, but if you're moving through absolute space with any kind of velocity, you can kind of understand that there's every likelihood that there's some other velocity that's affecting you, okay, that's not your local, any local imbalance, just like any violation of thermodynamics, any increase in entropy, decrease, is in a closed little systems. You can have little areas where you have these imbalances, but overall, the imbalances have to equal out. But anyway, even if you don't believe that, it doesn't matter. The speed that we're talking about the Earth moving through this absolute space is nowhere near fast enough. It's not like going half the speed of light in the spaceship and the surface of the spaceship is moving at half the speed of light, and therefore you can see the photon miss the other side. Which again wouldn't even be physically possible because the emitter also has to be moving very, very fast. Okay, which is a problem in terms of emitting your photon in coherent pieces. So, in the sense that if you're both the emitters moving, then you can understand that the polarization of the light would increase. And then you'd receive it, you'd re-decrease that acceleration. So in that sense, the one thing would be compensated by the other. Just as if I create redshifted light by moving forward, okay, or sound. Well, you sound because you don't believe in mechanical redshift when it comes to light. But yeah, light does the same thing, okay, as sound, in the sense of you can shift it based on your movement. So if I move away, I can redshift light, and if I move towards, I can blue shift the light by increasing the frequency. But all of that can be undone if the receiver is doing exactly the same thing. If the receiver's got the same motion, that is, we're tied on some body, the Earth, and the Earth is moving, well, the emitter's going to blue shift and the receiver's going to red shift. The emitter's going this way, pushing into the direction. The receiver's running away from the direction. So obviously the direction is going to be balanced in the sense that one causes blue shift going forward, the other one causes red shift running away. So it's like a boxer's punch. He's punching forward, he's got a whole bunch of momentum, but if the guy receiving is moving away, all the momentum's gone. All right. So that probably is enough of that. So again, they keep talking like this is something experimentally obvious. There's no practical way for us to do the experiment. Even LIGO, right? It has miles long, 2 mile long tunnels, right? Not even close to theoretically useful. So if they wanted, to detect their gravitational waves, they have to multiply those 2 miles by 1600. Okay, so they have to turn 2 miles into 3,200 miles. That's the truth. The tunnel's now 3,200 miles long. So just understand, even with a tunnel that long, okay, well, they haven't done this type of experiment. They clearly can't do it because they are so manipulating the photons already that you wouldn't be able to detect it because they've got so many instruments the photon is going through that you've already changed its pure straight line into a pile of crap. But anyway, that's a secondary. Superfluous to the points that need to be raised. Okay. All right, so anyway, so this idea that you can make one of these light clocks to detect motion, it really is dependent on really, really fast speeds to see any difference. So at the slow speed that the Earth is traveling, you're not going to be able to detect it. It's too small a difference inside of too big. It's like if we had a laser beam that could actually do a single ray of photons. Just one single tiny ray of photons. It might be possible, but we don't have such a laser. All right. So I did comment to that. That's like saying we have to constantly adjust the moon to the rotation and movement of the Earth. We don't have to adjust the moon because the moon's in the same field that the Earth is in. The moon is orbiting the sun. It's not just orbiting the Earth, okay? It's orbiting the sun, and it's in a galaxy, and it's actually orbiting the galactic center, you could argue, or the other side, the other arm of the galaxy. So it's already involved in lots of other activities. All right, so now to AB Science. A long comment, so you got to say, okay, I did provoke some thought on his part, right? Because they had to do all of this crap to find a way to rationalize an excuse for him not conceding something that's kind of obvious. But anyway, let's go. You have to consider what drag is. So this is the whole point. We're talking about a specific kind of drag. Drag caused by the existence of the smallest elemental momentum in the universe. So the smallest ultramundane particle, so small that obviously we can't see it, like gravity and radio waves and all this other stuff, and it makes up all this stuff, magnetism, gravity, all this stuff the WUI force spits. That's what it is, okay? It's this stuff that's really, really tiny, but there's a ton of it, okay? But it's really small. So an electron would be like this, and the little force bit would be a pin, a little pinhead. Right? So that would be the comparison, some sort of huge thing, okay? The electron would be huge compared to this little force. You don't even have to make it that dramatic, frankly. You could just say an atom, and a little force would be like pinheads. Some sort of analogy like that, okay? That the little force can move electrons, though, and it can move protons. It can give them momentum. And let's understand, he's mocking, ridiculing, degrading, insulting people who were making their conjectures 300 years ago, okay, before they had the advantage of all the experimental evidence. And I would argue that those people were so far ahead of these assholes. I mean, like the Aristotles and the rest of them, they were so brilliant by comparison. The fact that they could deduce so much out of so little evidence, the Galileos, I mean, insanely brilliant people by comparison to these fuckheads, sitting there pretending, oh yeah, I saw the obvious flaw in your theory. Yeah, no. You don't see shit. You don't think shit. You don't think carefully, that's for sure. Anyway, so now he's changing the definition what drag is. Drag in this circumstance just means that we've identified that there's a cause for the effect, right? That's the simple statement being made. There's a mechanical, physical, he called it mechanical gravity, and yet he's playing a game. We don't know what drag is. No, the whole theory is, right, and this is taught by Leonard Susskind, by the way. What I'm going to say now is exactly what Leonard Susskind, this is how he teaches general relativity and special relativity. This is exactly what he's going to do. He's going to use mock gravity as an example, except he doesn't have to account for it as a real force. So he just changes the ultramundane particle into a non-existent particle, a virtual photon, for example. He changes it into something for which he does not have to account for its momentum. It doesn't have to be conservative because it's not real energy. They just say it's the magical give you energy particle, but it's not real energy. You didn't have to get it from somewhere. The magic gave it to you. You drank the magic beans, the magic bean juice, and it gave you magic energy. All right. So let me just, okay. You have to consider what drag is, and then you'll find that it doesn't make sense to talk about these what is this microscopic phenomenon on this scale. So the whole conversation is about exactly that, this microscopic scale, and what's happening to the bits, the atoms. So we know the atom is made out of these particles, okay? Let's not pretend it's some other truth here, okay? Atoms are made out of particles. They're made out of something else. They're not, there's no atom thing. There's the bits of the atom. All right, so we know we have the two components would be the electrons and the protons. Essentially, you got the positive nucleus. The electron is, I would say, magnetically, through charge. It's not orbiting and all that crap. You don't need any of that shit. But anyway, they're the things that move. So if I move, what's happening? The whole argument is that the ultramundane force, okay, moves electrons and protons. So the electrons and protons are moved by the ultramundane force, okay, and they find a new position, okay, and that's how something's moved. Something doesn't just move. The atom doesn't just say, I'm going over here because the non-existent magical entity, space, told me to. Space said I have to go over here. No, the argument is a real particle does it. So everything that moves, moves because something more hit it in one direction than the other direction. That's the simplest way to make it. All right, I mean, that's the fundamental argument of a particle gravity, is that you have more stuff hitting it from one direction than the other direction, therefore it moves overall in this direction. And the drag argument is simply the fact that if I am moving in this direction, I'm going to incidentally, eventually, right, not instantaneously, right, this is random. So we don't know how fast it will be that I will run into this extra field, but you just know you're going to. So if it was birds, okay, let's say there was hummingbirds and they were hitting you from both directions. When you're moving into the field of hummingbirds, you end up hitting more hummingbirds, in the direction you're moving. So obviously, eventually, wow, that's a pretty big earthquake kind of thing. Eventually, right, I'm going to end up hitting more birds forward because I'm shortening the distance. They were coming at me this way. I'm going to shorten the distance. They have to travel less distance to get to me. So it's going to happen sooner, in time. I'm going to end up crashing into an opposite bird, right? And that's drag. So drag just means that eventually, okay, not instantaneously, eventually, if you move into the field, any piece of space, if you move into that space, you will be hit by more stuff. You will collide in the forward direction with more stuff, and less stuff will be able to catch up to you, right? Because you're moving, even if I'm going 2 miles an hour in a direction, the stuff going 30 miles an hour chasing me, right, theoretically has to go 32 miles an hour to catch me. It has to go, it's going to take it longer. It's less likely to hit me. That's drag, okay? That's the subject. There's no misconceptions here. That's what the whole particle theory depends on. That's what the guy was saying 364 years ago, or whatever the hell it was. That's the elemental argument. Yes, he didn't know about electrons and protons, but he was clearly arguing that the elements of something's materiality is what this ultramundane force is affecting, is the elemental bits. So first he premises that as if, oh, you're not understanding. No, you're not understanding. And now you're going to clearly evade. So this is his premise. Oh, you have to know what drag is the drag is dilemma. No, bullshit. All right, drag arises from a large number of particles. It has nothing to do with a large number. It theoretically all it has to do with is the yin and the yang, the idea that you have two equal amounts on either side. Now, obviously, you have to have some force, or you haven't got anything happening. But clearly, the drag argument was ultramundane particles, and that there was an insanely huge number of them. That's the premise. That's what the Fadio guy was saying 350 years ago. So let's not pretend, oh, he doesn't know what the concept is. No, that's clearly the concept. All right. Drag arises from a large number of particles in a solid object hitting a large number of particles in that fluid. So the argument would be is that it doesn't have to hit a large number. So the argument would be is that I can create drag by creating a theoretical electron and just say 1 an hour comes from this direction and 1 an hour comes from this direction. And that means the electron won't go very far. It'll just do this. So, this idea that you have to have streams and rivers and all that kind of crap, no, all you have to do is have force and opposite force. So all you have to do is say the universe is balanced. It's hitting everything equally from all directions, okay? And, there's an even amount of pressure from all directions. It doesn't even have to be, because we wouldn't know the difference anyway. But let's just suppose it. And now all you're saying is the fact is the thing isn't going to go anywhere. Now it's going somewhere. It's going back and forth, but it's not getting anywhere. All right. So, so yes, already the concession is large numbers and all that kind of stuff. But I'm just saying that from the electron's perspective, it doesn't matter whether it's getting hit every millisecond or it's getting hit every hour. The point is that there has to be an imbalance in the field. Something has to change the balance of the field, and that will decide where it goes. So whether it goes 1 mile an hour or 10,000 miles an hour, what speed it travels at, all of that doesn't matter. The point is it has to be hit by the ultra-mundane force to move. It doesn't move because it wants to. It doesn't move because it's stored some energy. It moves because a force hits it, pushes it, and then while it's being pushed, the force is obviously slowed down, while it's carrying the object, and then the opposite force releases the force. Okay. It doesn't make sense to think of electrons this way. Well, to me it makes perfect sense, because electrons are why we move. The electron moves first. So again, their physics is we move and we drag our electrons with us. So our body decides to go somewhere, and then it tells the electrons, you have to go with me. No. The electrons move first, the protons move first, then the atom moves, then the object moves. So they don't even understand the physics here. They don't even understand that the movement starts with the electron moving and the proton moving. It doesn't start with the atom moving. Okay. Electrons this way, as your solid objects would just be a single particle. Well, that's what it's made out of ultimately. That's right. All the big things are made out of little things. Amazing. Of course, your single particle can hit a particle in the medium and interact with it. That's exactly the point. The electron is seeing, let's say, light kind of the same way we are, you could argue. It's seeing it as pieces of momentum that are going to hit me. Now, obviously, we're very frequency sensitive, so we have different compounds and atoms that are going to be affected more by certain frequencies, because that's going to cause the electrons to escape their atoms and ionize the atoms and all that kind of stuff. But the general principle is just that simple. It's energy. It's shot at me. It's more particles coming at me from one direction. The other side doesn't have a light bulb, okay? And so you know that theoretically, if I could just make this simple experiment in space, I put 2 light bulbs in space, and then one of them burns out, and you were right in between the 2 of them, that you would end up drifting away from the side that has the light bulb. Okay, of course okay, you already did that with it. This is what limits the range of an electron. Okay, so of course your single particle can hit a particle in the medium and interact with it. So he thinks electrons actually hit electrons. They don't hit the field, the charge field around the electron. I mean, what's your argument here? See, this is where it all breaks down. Is because, see, I'll say something like force bit, and they'll say that's trivial or baby talk. You have to distinguish between these particles. It makes no sense to call the water in the river particle, and then call the boat particle, and then call the person particle. It's stupid, all right? They have to be identified as different particles. Force particles versus matter particles. You have to make a distinction between the two. One are moving all the time. The others don't move until they're hit by something. I mean, they're fundamentally different. Anyway, so this sentence can't make any sense because he's calling a force the same thing as the electron. The electron isn't a force. The electron can be moving, and if it is moving, it's because there's a force pushing it. Okay, this is what limits the range of an electron, but it is wholly different to drag. So there's no way to make sense out of that, right? Of course you can, your single particle can hit a particle in the medium and interact with it, okay? This is what limits the range of an electron. So again, I'm telling you, let's put it in a vacuum. So I clearly stated that. So now there's less likelihood. It's not creating vapor trails anymore. It's not plowing through atmosphere. It's not plowing through some dense material where there's lots of other electrons for it to plow into. I mean, theoretically, a vacuum has no electrons in it, right? I mean, an electron is charged. It sees everything. When it looks at the world around it, it can never see balance. It always sees a charge differential. There's always one electron closer to it than the other electrons. There's always one proton closer to it than the other protons. There's always a place that's going to be, I'm going that way. So electrons in free space is a silly idea, unless they have momentum. A single electron placed anywhere in the universe will not just sit there and say, I'm perfectly happy here. There's no possibility. Just by the laws of Maxwell, the fact is that there's no way to create balance in a dense field of charge. There's no possibility of ever creating a balance where the electron says, oh, I'm just as close to all the objects in that side of the universe as I am to the objects in this side of the universe. That's impossible. Anyway, moving on. So I mean, I'm just saying a vacuum is a pretty clean place, and there's nothing theoretically to stand in the way of an electron just zooming right through it. All right. Yet he's pretending there is. He's telling us, no, there's still something in the way. The electron is still has a problem somehow. It can't make progress. All right, anyway. This is what limits the range of an electron. So again, I've asked you to think of it as a vacuum, and I'm just telling you, if I shoot an electron in a vacuum, how far does it go? And he can't answer the question. But it is wholly different to drag. So he says it's different than drag. He says the electron doesn't go very far, and it's not drag that stops it. It's some other miraculous event that takes place. It has an interaction with some kind of magical thing that stops it from moving. All right. So in a true vacuum without any fields, I didn't say there was no fields in the vacuum, right? We didn't even talk about that possibility. So again, nobody's ever suggested a vacuum stops magnetism. No one suggested a vacuum stops light from propagating, right? Vacuums, I can put a light inside of a light bulb inside of a vacuum, right? Because that's how they're made. Pump the air out, put a gas in. But I'm just saying you can make I mean, the first light bulbs were take everything out, don't put anything in, as much as you could take out. The more you could take out, the better it worked. So again, this is how could he say something like this? So in a true vacuum without any fields, what do you mean? Fields of what? I'm saying fields are, of course, light is a field. Light is energy. Magnetism is a field. What are you talking about? The only thing that doesn't propagate in a vacuum is electricity. Your phony electrical field is the one that has a real problem. Oh, anyway. Without any fields, an electron would just continue traveling in a straight line. So he told me that, but that's not what I said. I asked him for a piece of experimental evidence. Give me something to see. Where do I see this effect being demonstrated, this electron keeps going thing? Where's the experiment that demonstrates the electron just keeps going and going and going and going? I'm saying there's no such experiment. They've never been able to do this experiment. If they could, guess what? See, the truth would be is if they could take advantage of radiation, beta and alpha decay, they wouldn't have to make steam to make nuclear power plants. They could do a direct conversion. They could take radiation and directly convert it into electricity, because all they have to do is separate the beta from the alpha. All they have to do is separate the charged particles, and then they can create electric potential, and they don't have to do all of this heat nuclear thing. They can just directly convert it into electricity. But it happens, and it's just too small a range. They have to put this stuff too close and create too much trouble to me, to get the electrons. Because they don't go far enough. If they could create a vessel, like I said, they put the nuclear crap here, and they put the vessel out here, and they could just collect the electrons on this bottom surface and collect the protons here on the top surface. Bingo. They could just charge the plates, get a gigantic voltage, and they'd be in business. All right, well, anyway. So in a true vacuum, without any fields, an electron would just continue traveling in a straight line. Simple conservation of momentum. So again, he's just saying we have a law. Heisenberg says so. I don't have to prove so. I don't have to show you so. And I would argue that every experiment that I know of that's ever been conducted demonstrates that I can't do it. I can't make an electron gun in any real sense of the word. The gun goes a centimeter. The bullet fires, and 1 centimeter, that's as far as the bullet's going to go. I don't get anything out of the gun. All right, and we know that like I said, the voltage potential thing, we know that has huge limitations. So that doesn't even work. Their gun doesn't even work as a theoretical gun because it's not really firing electrons. If I have an accelerator, linear or circular, I have to keep increasing the voltage potential. I have to keep shoving voltage potential in to keep the electron moving. It stops as soon as I stop accelerating it. So no evidence of it there. They have these giant 2-mile LIGO tunnels. I'm sure somebody could just say, well, let's do something. Let's do a different experiment for just today. Let's shoot some electrons and see if we can get the electrons to go the 2 miles. They won't do it. Okay, they can't use electrons to bounce the electrons off the surface of the moon and get some back, and they can't use them in any gun sense at all. They can't give electrons any kind of momentum and get anything back. Get anything to go anywhere. All right. And that's what the evidence indicates. So again, he just throws the principle. Simple conservation of momentum. I say so. That's all he just did. He just said, I say so. I won't demonstrate so. I won't prove so. I won't even give you reason to believe. I'm just going to declare it as a fact. All right. There just isn't any evidence. He says there's no evidence. I say all the experiments point to electrons don't go very far. And it doesn't matter. I can take all the obstacles away and they still don't go very far. All the visible obstacles. To suggest that electrons experience drag in any way. So there just isn't any evidence. There's no evidence that they do anything other than get dragged to a halt. That's the simple argument. There's no experiment that demonstrates the electrons keep going. I give them momentum once, and like a wrench in space, they just keep traveling. No evidence. They don't come from outer space. They know it. We're not getting bombarded by, when a sun supernovas, there's not a whole bunch of beta particles hitting us. Not a bunch of electrons flying through space and they bombard into our atmosphere. None of that happens. Big giant things come in and they hit the atmosphere and they break into electrons. Muons are created in our atmosphere. They don't come from outer space. They don't do any of that kind of stuff. They're created in the atmosphere. All right. So this just, so he says the experimental proof is that somehow electrons do keep going forever, and that's been demonstrated by every experiment, and I'm arguing clearly. No, every single experiment demonstrates electrons don't go forever. Every single one. Anyway, electrons experience drag in the way you are thinking. We would notice this in accelerators. So I said to that funny line, right? We would notice this in accelerators where we are constantly accelerating. Constantly forcing the electrons. The electrons jump across a voltage potential. Then they force the electron to jump across another voltage potential. Then they force the electron to jump across another voltage potential. The only way they can keep the damn electron going is to keep pushing it. They have to keep injecting energy. Again, what's the electric bill at the Hadron Collider? For every experiment they do, their electric bill is like $1 million. Okay, I mean, they have to use an insane amount of energy to keep these little tiny particles moving. Okay, there just isn't. Okay, sorry. Yeah, so I answered him by quoting him. We would notice this in accelerators, and I state, newsflash, accelerators have to constantly keep accelerating the particulates, or the particulates lose all their momentum to drag. And that's what they're losing it to drag. The fact is, they are moving into a field of energy, the universe. The universe is energy. The cosmic background radiation, as an example, right? If I move an electron, it's moving into more cosmic radiation from the side it's moving into. So we can't deny drag, because drag would logically exist even if we only account for cosmic background radiation, right? So it's coming from all directions. Right there we already have drag, right? All I'm arguing is, well, yeah, there's a lot more than just the background radiation that we can see in the microwave range. There's a whole bunch of it that doesn't have a frequency. There's a whole bunch of it called gravity, okay? And the particle of gravity. And it's hitting us all the time in this little ultra mundane way that makes it possible for us to be accelerated without even feeling it. It's so ultra mundane. It's so gentle. It's moving the electrons and protons, and it's moving them in this so gentle way, because it's like there's some idiot, right? The other guy who I did a couple of videos of, right? Well, he takes the most powerful flashlight in the world and he sticks it in his mouth, and he shows how the light is actually coming out of his eyeballs, right? Because the light goes right through his skin, his tissues. It goes right through it. So I mean, this idea of that, oh, everything is blocked and everything's stopped, and no, everything is just kind of pushed along, and gravity pushes you so gently. It pushes your little hairs on your head at exactly the same speed as the hairs on your toes. I mean, it pushes it all at once, and therefore you don't feel a thing. You don't feel a thing. Why? Because every part of your body is being moved exactly the same at exactly the same time. There's no unevenness. The only time you feel acceleration is when the acceleration is uneven. So this is one of the simple physical factual truths of physics, and none of them know it. Not because Einstein didn't tell them this simple little truth. Einstein told them another fable that's completely silly, which is all acceleration is the same. So if I shoot you with a bullet to accelerate you, it's the same as me gently shoving you down the stairs or something. No, it's not the same. The bullet's really inefficient. It moves some of your little bits really, really fast, but it moves most of them not at all. Where gravity, you never feel a thing. You won't feel a thing, ever. Because it's ultra mundane. Yeah, it's moving electrons and protons. And it's moving them all, okay, because it floods the empty space between the electrons and protons. It floods everything. And it can go through lead, and it can go through miles of earth, and it can go through all kinds of stuff, because it's really, really, really dense and really, really, really small. So anyway, he hasn't touched on the real argument, just more of this propaganda. Maybe I'll just leave this as the comment video. We'll see if we get any other comments. Because I don't need to play the video in a sense, but I will play it just because, to mock it. Because it's all just Wikipedia page, and it's all subjects we've already, frankly, I've already dealt with all of them. We know the only argument against the particle theory of gravity is the drag argument. And the fact that you just have to explain why two big things store velocities and momentums. Somehow if I throw them, they get to keep it. They get to keep that direction. When you throw an electron and a proton, it doesn't get to keep it. That's the big difference. And I have explained that you can create a mechanism in, the structure of atoms that ends up capturing momentum in a direction. And it'll just keep going in that direction. That there's actual physical structures that the more pressure you put on them this way, against, they create more pressure going this way. They accelerate. The more you compress them, the more they accelerate, the faster they go. That they have a direction built right into their structure. And the key would be is that neutrons, okay, with a proton or two, a helium nucleus, the only thing that we know actually does travel across space besides photons. So besides this stuff going the speed of light, the only thing that we know of that can actually travel from the Earth to Alpha Centauri in a straight line and actually get there is a helium nucleus. How come? Well, because it has a structure where you compress it with drag, you push harder on its nose, and it pushes back with its wings, so to speak. It pushes back. So the harder you push against it, the harder it pushes in the direction. And that's why matter keeps going. And electrons and protons don't. But anyway, he won't deal with any of those arguments. He won't deal with any of these mechanics. So let me just do it quickly. The rational theory of gravity that doesn't depend on bent space. So again, throughout his whole video, he keeps talking about how their theory, their vacuous theory of the magical geodesic, satisfies the inverse square law. The point isn't to satisfy the inverse square law. The point is to explain why there is an inverse square law. Particle gravity explains why there is an inverse square law. It explains why, okay, just like this hand getting 4 times bigger, half the distance, that's the inverse square law. The light bulb is the inverse square law. Now, you don't have any continuity problems in terms of thinking about a light bulb, because you're saying, yes, a bunch of energy is going in and the energy is just flying out. Now, somehow the Earth and gravity mechanism, there's no electricity that we can see, right? We can't see the cause of the inverse square law. We can only assume that it exists. And it's doing exactly the opposite of the light bulb, right? It's consuming somehow more stuff goes in. Just like, I'm just saying, if you just reversed the concept, what does gravity say is happening? So when Leonard Susskind teaches it, well, I'll go there. The most highly, the guy who's supposed to be the guru on the subject, the guy who knows it better than Einstein himself, teaches Einstein. What does he use? He uses particle gravity. I mean, it's so hilarious. That's actually what they do. They actually use the theory of particle gravity to explain gravity, relativity. So that's where this really gets preposterous and silly as a lie and a pile of crap from these assholes. Anyway, so Leonard Susskind says, okay, you have an object. What do you have? You have an anti-divergence. That is, you have this idea that things like opposite of a light bulb, right? You have an anti-divergence in the sense that everything's converging, right? So that would be an anti-divergence would be a convergence. Now, he doesn't say convergence for whatever reason, right? He's just afraid of the concept. But what he's basically saying, this is exactly what he'll say. He'll say gravity is like 2 pieces of glass. Okay, so just think that that's the world you live in. It has these 2 pieces of glass and there's a little separation. And the universe is basically providing an infinite amount of source water comes in from the outside. Okay, and you have a hole that is matter. Matter's a hole, and an infinite amount of water goes out the hole into no place. The infinite bucket. So there's an infinite bucket, right? The infinite bucket holding the infinite amount of fluid that comes out of the infinite universe, and then somehow the bucket is poured back into the waterfalls that fill it. So I'm just saying there's no energy conservation because they don't consider any of this real. None of these things are real. So it acts just as if, this is how they teach it, I'm telling you. So they have to teach it as an energy theory, but they don't have to account for how did the energy get back out again. So when he says so he has gravity just saying, look, it's like water. And, the moon gets caught in the water flowing. The river's flowing towards the earth. So this is the earth. The moon is being pushed, by the flow of the river, but it has a motorboat. So the motorboat keeps it moving in a direction. And so it just goes around and around because it's getting pushed in. And so its straight line of its velocity just gets bent, and because the river's pushing this way. And so, but there doesn't have to account for where did the river come from and where does the river go. So, but that's the irony of it, right? Because bent space really is just a funnel, right? Bent space is just a funnel. It's just saying, oh, the universe is a funnel. Every piece of matter is a funnel, and stuff goes into the funnel, and that's all it's saying. It's just converting it into a two-dimensional system when it's really a three-dimensional system. It's just cheating so preposterously. It's using gravity to explain gravity, right? That's what a funnel is, right? Funnels don't work in space. So this is so pathetic. That they're using the particle model to explain their stupid relativity because they have to use something. They have to make sense out of it. And all it is a free ride because they don't have to explain that it's not real energy. This isn't real water. This isn't real substance. It's some sort of bent geodesic magic space. I mean, you could have done this with light, right? They would have done this with light, right? Let's say if there was a light bulb, okay, and the light bulb just burned, okay? I didn't have to put any electricity in, right? The light bulb just made light, okay? So say if I found a little piece of rock, okay, I mean, radium actually does this, okay? But let's say I did it, more dramatically, where you could all see it. And the little piece, the light bulb was perpetual. It just did this forever. It just produced light forever. How would I explain it, right? How the hell do you explain that? I mean, how do I make a conservational theory? How do I explain how anything, like it's magnetism, right? All these assholes have magnets with all this flowy stuff forever. Somehow it just perpetually creates flowy stuff that's moving around the magnet. I mean, all this spiraling, moving crap. How does it do it? Well, then I'd have to come up with some bent space, right? Some sort of magical source of energy. Because where's it coming from? Where is the little bits of waves, whatever you want to call them? Where is the energy for that coming from? What is making them? What's wobbling and how is it wobbling? So they have no explanation. So you have to make jellyfish at the center of everything. Everything has to be a jellyfish or something. It's bullshit theory. But I'm just saying, if there was a light bulb that burned without energy, you'd be just as stuck, and you'd end up saying, well, bent space would explain it. What if space is bent and the light bulb has bent the space and now the ether is all contracting? Well, that would create the waves. Some sort of nonsense theory. You'd have to come up with something. So but it would be nonsense. Okay, it'd be garbage. It'd be stupid. So the simple explanation for gravity is that electrons, when you move them, they actually consume a little bit of momentum out of the universe. So when a little bit of particle force hits an electron, the electron, okay, well, I just drew it the wrong color. The electron is moved by the force because the force gets stuck. Ooh, he's stuck. So here he's moving the speed of light. Here he's moving minus the speed of light, something less than, because he's moving this electron some speed slower than the speed of light. And now it hits the opposite force, drag, okay? It runs into a force going the opposite way. This force reflects, this force reflects. Now the electron isn't moving, and the forces have gone back to their normal speed. That is, now there's a force going this way, and there's a force going this way. The universe is back to being complete. But the fact is that this force, now this force reflected, so that's not a problem for it, but this force clearly was going the speed of light and would have been here in a certain amount of time. And now it's only going to be here in a certain amount of time. It's going to reflect here. It would have been here in space, but now it's going to reflect here. Okay? It didn't get as far. It should have been here. It's here. Therefore, it traveled a distance in less than the speed of light. So now a little bit of the energy from the universe has been consumed. So all you have to do to fix, to overcome his argument that somehow we have to believe in bent space and we have to believe this preposterous theory of a non-mechanical universe, all you have to accept to say, oh, all the problems are solved, is that the force, okay, doesn't just bang into something and bounce off. The force doesn't hit it and then drop dead and disappear in the universe. No, that it actually hits it. It actually goes into it, sort of, and pushes it, and then is released by the opposite reaction. That's it. So this simple understanding that it's not about bouncing off of something, it's not about breaking things into pieces, it's merely about the thing is like moving slugs, right? So little slug particles in space, and you can sort of understand the slug hits you and it sticks to you, and the whole time it's stuck to you, you now are going to absorb its momentum, and the slug isn't going to pop off into you until another slug moving the opposite direction hits you in the back, and then the slug will pop off. Okay, but not until then. That simple analogy fixes all the problems, but that's too much for you. But you'll accept bent space, you'll accept dark matter, you'll accept virtual photons, you'll accept entangled photons, you'll accept all kinds of wooey bullshit about spins that don't exist and energies that would be perpetual energies that don't exist. Again, and orbiting electrons. You accept all of that crap, okay, based on no evidence, and that it's completely logically impossible. And again, Leonard Susskind, the authority on relativity, teaches it as particle gravity, as Mach gravity, as a fluid dynamic. I mean, these people are just so dishonest, so duplicitous, and such cowards because they're running from this argument. They won't address any of the points I've raised in this video. AB Science will not respond. Coward. All right. So, that's enough. All I can do is reason with you people. And yes, I'm doing it angrily because it's 10 years of this nonsense. 10 years to have to explain something like there's only one universe and it's the small universe. 10 years to have to get them to admit their evidence is insanely weak, that they don't have a big pile of geological evidence and a bunch of fossils, and this isn't anything like an evolution theory where a whole bunch of evidence has been compiled. They have crap as evidence. A crappy Eddington experiment, a crappy, merely a tangential association between nuclear decay and velocity. I mean, if I went out and I could ask the question, right? I could go out onto the streets of America and ask basic citizens. I could say, what do you think will happen when you accelerate a piece of uranium? Do you think it'll decay faster or do you think it'll decay slower? Right? Now, at first I could fool them by just giving them those two choices, right? And they wouldn't even realize that, oh, I could say it won't change its decay rate at all. But you would think that, oh yeah, well, moving it, oh, that's got to make it more vulnerable to decay. But, you can logically deduce that, well, what is causing decay? And how can I change how fast something decays? Well, I can change how fast it decays by putting more decay elements closer to each other. If I put the atoms of uranium closer to each other, all of a sudden I change its half-life. So all you need to do to change the half-life of a radioactive element is to put it closer to another radioactive element. So clearly, whatever's causing decay, it has to do with the environment. It has to do with stuff coming from the environment. So obviously, if you're moving a decay product, oh, that might change its decay rate because I'm changing its environment. And maybe decay just has to do with the fact that it needs to have equal pressure on both sides. And if you uneven the pressure, it's less likely to decay. There, solved. But they won't do any of this logic. Oh, anyway. They're just such cowards. Horrible, awful, terrible cowards. So till the next time, and such and so forth and whatnot. Yeah, I'll play the video next time. And but again, you can already see how preposterous his understanding of Mach gravity is. So he just recited a partial glimpse, the superficial Wikipedia page glimpse at the history, and he doesn't really even understand what was argued. And he's a physicist. He doesn't understand such a basic concept. All right. So till the next time and such.